Today I'm going to talk about some more of genetics, dealing with how humans, our species, Homo sapiens sapiens, evolved. There's a study that I've linked in the description. The second link where it says the full PDF. There's a little bit of a I'll tell you the link when I get there, because there's a little. You have to download the PDF of the study, and there's also a study that I think is yet to be published, which this article deals with. So before I get on, I'm gonna say hello to the people in the hangout. Hello, Sam Blake. Hello, Warped. And Carlos David, my dear friends, John the Bemused, Malefice, how are you all? I'm going to jump right into the article, as it'll be short, and I have a little bit of surprise at the end, so stay for the end, because I will surprise you all. And let's share the article. So sharing the screen right now. Yeah, this article talks about it's from New Scientists, and it states that it takes only a few genes to tweak to make our voice happen to get our voice, by Andy Coughlin and so on. How and when did we first became able to speak? I'll make this bit better. Here we go. Even better. Now it's clearer to everyone to see. The new analysis of our DNA reveals key evolutionary changes that reshaped our faces and larynxes, and which may have set the stage for complex speech. The premise of this study is that we speak the way we do as a result of evolution forming how we look, our cranial and our throat shape. That's the premise of the study that's in the description. I'll talk about that a bit later on, but let's keep reading the article. The alterations were not major mutations of our genes. Instead, they were tweaks in the activity of existing genes that we share with our immediate ancestors. So basically, we primates have. If you just heard that, that's me opening my beer, and it's a Spanish-produced American oatmeal stout for those beer lovers. And I haven't tasted this, so I'm gonna see how good it is before I continue, because I think I deserve a little pampering. And it's approved. Very good beer. Wizard of Course would like this beer. Now let's get back to the actual article. We share genes with our primate ancestors, and they are expressed differently between each species. That's what more or less this is saying. The changes in gene activity seem to have given us flat faces by retracting the protruding chins of our ape ancestors. That's why our chins are more or less parallel with our eyebrows, in fact, with our protruding occipital orbs where our eyebrows are. They also resculptured the larynx and moved it further down in our throat, allowing our ancestors to make sounds with greater subtleties. That's the presumption of this hypothesis. The study I am getting. Yeah, I was speaking clearly, so I don't need to keep going about that. I mistrust this microphone, which is not was quite cheap, but the sound's not too bad. But uh, I'm sorry, guys, that I won't be able to see your tweet your comments in the chat. Um, but hold on, and I'll try and answer them after in a surprise. But let's get on with this. Um, the study offers an unprecedented glimpse into how our faces and vocal tracts were altered at the genetic level, paving a way for our sophisticated speech we take for granted. Yes, we take for granted our speech, except when it's taken away from us, but that's another story. However, other anthropologists say changes in our brain were at least equally important. It is also possible that early ancestors could speak. I agree with that, with this statement, but in a more crude way. I don't agree with this statement. We don't know, and that the facial changes simply took things up a notch. Possibly not. I don't know enough yet. I don't know genetics, by the way, so that's my caveat. I don't know genetics, but I do know anatomy, enough of anatomy to make quite a good um, um, analysis that's quite valid. It will stand up to scrutiny. Now, Liran Carmel of the Hebrew University of Jerusalem and his colleagues examined DNA from two modern-day people and four humans that lived within the last 50,000 years. They also looked at extinct hominins, two Neanderthals and the Denisovians. So they basically got DNA from two modern humans, modern Homo sapiens, and they've extracted the DNA from four Homo sapiens about 50,000 years old. They also have DNA material, DNA, the DNA genome maps of Neanderthals and Denisovians, thanks to the Max Planck Institute. And they looked at those genomes, and they compared it to 6 chimpanzees, which the DNA from 6 chimpanzees, and data from public databases supplied by living peoples. They may have even used mine, because I gave my genome. I had my genome analyzed in the late early 90s, 91, 92, when National Geographic was doing their genome project. And it came back to me that I have 3.5% Neanderthal. Mostly, I have primarily Celtic Roman DNA in me. And then the third component is Germanic. And then the rest is Neanderthal, 3.5%, and 1.8% other, which they didn't specify. So yeah, so that's their basis for this this study. They looked at 4 genes that became more or less active over the course of evolution to identify these epigenetic changes. This is basically just genetic changes. It is not going into morphological changes of our anatomy, etc. They examined whether genes had methyl groups attached to them. I don't know what that means. I honestly don't know why the methyl groups are anything, but it says that in general, methylated genes which have methyl groups in are switched off, and unmethylated genes are switched on. That means when they are methylated, they are regressive. They don't work. Work's not they don't operate. They don't function. That's better. They don't function. When they are unmethylated, they work. They function. That's basically what this is saying. I don't know genetics. I can't comment on the genetic part of it. I'm reading what I'll take it I'll take it as for face value that they know what they are. It's in the study, the PDF that I've included. I'll show you guys in a little bit later the link to it. You can download it and read it at your leisure. Because the link I provided you is just a summary of the first part, the abstract of what the study is. Sometimes the words can't. Oh God, never mind. Modern humans show dramatic. So by looking at the changes in methylation patterns, okay, the researchers could track gene activity cracking up or down. That means if they find methylated gene, these genes, methyl groups attached to them, they have been repressed. They're not functioning. And if they are unmethylated, they are functioning in those the samples that they gave up here, which is 2 modern humans, 4 ancient humans, 2 Neanderthals and Denisovians, and 6 chimpanzees, plus data from anyone who's given publicly their genomes to be analyzed. That's basically it. Modern humans show dramatic alterations in the activity of genes associated with facial shape and larynx shape, compared with our forebears. And our forebears, they are assuming the Neanderthals and the Denisovians. I don't agree. Our forebears would have been, as I've said in other videos which I've made, Homo heidelbergensis. They are the direct ancestors to us, to Neanderthals and Denisovians. And the fourth one, which we don't only know of their genetic makeup from the Andaman Islanders and a few other islands in the Southeast Pacific. So that's what they are comparing them to. The problem is we haven't been able to extract DNA from Homo heidelbergensis. The oldest DNA which we've been able to extract and actually map has been the Denisovians from more than oh God, I can't remember the dates, but 50, 60, 70,000, 60,000 years ago. So that's why we can't compare to our direct ancestors. I've talked about that, the oldest Homo sapiens skull that which was discovered in Morocco lately, and they are now beginning to question that, which is good, honestly. If we can extract, I can't recall if they have extracted any genetic material from that fossil, but if they do and when they do, and they analyze and they compare it to us, that will settle it. So just saying. And I am absolutely waiting for those studies. I love those studies. Anyway, let's get back to the article. And I'm just going to have another sip of the beer, which is bloody awesome. Ooh, nice. I'm just enjoying my beer, guys. Sorry about that. Anyway. Anyway, in particular, the genes linked with the vocal cord and larynx development were the most significantly altered compared with our ancestors. For example, there's a gene called the NFIX, was much less active in humans. It is crucial to jaw protrusion and larynx development, suggesting its dwindling influence allowed our faces to flatten. The researchers argue that this allows humans to develop optimal architecture for speech, in which the vertical and horizontal components of the vocal tract are the same length. And it's a C diagram. This is the diagram that this article posts. This is the one on the left is a chimpanzee. We have the color markings, the tongue, the hyoid bone, the epiglottis, and the vocal cords, compared to a modern human. See the protruding face compared to a much flatter face. I mentioned, let's see if I can see the Exactly. That's takes a bit long. But here, where my cursor is where our brow ridges are, eyes are. It's not as well shown in this article, but it's more or less vertical to what our chin is. So we do have a flat face. Now, if we draw, also can see that our vocal cords, our epiglottis, our hyoid bone are quite vertical compared to the chimpanzee one, who apparently has a bigger tongue or bigger area tongue, excuse me, than what we have. And the vocal cords are much larger in this diagram, at least. It's just simple. I won't comment on that. It's the actual study will probably clarify this. I haven't fully read it because I only saw it today, so I will read it, of course. Now, none of these changes in gene activity were seen in the other species studied. We conclude that voice-affecting genes are the most overrepresented as differentially methylated genes in modern human lineage. I've read this sentence more than once and I still don't really know what he's saying. We conclude that voice-affecting genes are the most overrepresented as differentially methylated genes in modern human lineage. That the genes that affect our speech are mostly switched off. That's what I got from it. I've talked about crappy journalism, science journalism, and especially in my field, archaeological journalism. And I am just, no, this does not make sense. The researchers wrote, our results support the notion that evolution of the vocalization apparatus of modern humans is unique. Fine, in genetic terms, they are. Carmel declined to comment on the results because they will appear soon in a peer-reviewed journal, and I hope to get that journal. Just a bit of a break. New people are in the chat. I should go back to the start. Beige Price, Jan Holding. I hope I spelled that right. Papa Pika. MWM Media, hello. I enjoy your videos. Sometimes I don't have enough time to share them. I'm sorry for you, just getting a bit off thing, but I apologize if I do watch your videos. So just I apologize if I don't press the like button enough, because sometimes I don't have time and sometimes I'm on my mobile. So that's my excuse, and I don't have an excuse. I apologize. I don't have an excuse. But anyway, let's get back to what's important. Now we're getting to the part of the article which argues against. There's no refutation. There's no debunking. No, in science, you don't debunk. You present an opposing argument, an opposing data, or opposing etc. You don't debunk. You don't refute. Data speaks for itself. And however, other researchers say that the study, while important, does not tell the whole story of speech evolution. Yes, it doesn't. I should say, no, it doesn't. Exactly, that's correct. It does. Simplistic studies are fine, but then you have to link them with all the others to get the broad picture. Now, in particular, changes to the brain's ability to process vocalizations made by others may have been just as important as anatomical changes, if not more so, says Eric Trinkhaus. at the Washington University of St. Louis. Eric Trinkhaus, I know him. I read him while I was studying archaeology. He is cool. He's okay. He's fine. There are no superstars in archaeology these days. There used to be. Louis Leakey, he's still alive. He's still like the Leakey family are one of them. The Beetle type things. But Eric Trinkhaus is and Portuguese archaeologist named João Zilhão. It's bloody hard for anyone else to pronounce it. João Zilhão. That's how you pronounce it. Spelled J-O-A-O with a till on top of the A. Z-I-L-A-O. Zilhão. It's Portuguese. Never mind. It says that anatomy doesn't impede primates from producing distinct vocalizations that are homologous to different human valves. Adriano Lameida, that's a Portuguese name, if I ever seen one, at the University of St. Andrews in the UK. He has previously shown that orangutans can mimic some of the sounds of human speech. I haven't clicked these links, by the way. These in blue are the links. Click them, guys, if you want to have some background reading. I will do that, but for now I haven't. I don't lie. I tell the truth, and I haven't clicked on all the links. And I've clicked on Eric Trinkhaus's link, of course, because I know him. But I haven't seen this study. And there's a 2016 study that found evidence that monkeys' vocal tracts could produce speech-like sounds if only their brains could control them precisely enough. Of course, these findings is disputed. Of course they are. And I'm not going to say they are correct or not. They will be proved, they will be settled once the science comes in. That's how science works, by the way. Now, speech may have gradually improved over the course of hominin evolution. There is evidence that Neanderthals and Denisovans could speak, at least to some extent. Last year, in South Africa, they discovered a totally new hominin species that lived at least to 280,000 years ago. He was a small capacity. God, I can't remember the name. Let's see. Homo naledi, right? Homo naledi had a brain capacity of about 500 cc's. That's less than half of what ours have. And when they produced 3D scans of the skull, and then they can work their way back to actually almost make a mold of the brain, they found that Homo naledi had the cortex, frontal cortex, or the part of the brain that governs speech, that was quite developed. So this statement, I'll take it with a grain of salt. I will dispute it. I personally believe that Neanderthals could speak almost as sophisticatedly as we did, but there's been studies and vocalizations that they may have screeched high-pitched sounds. That's a possibility. I might cover that soon, but in one day. But for now, I will settle that. We'll say that Neanderthals and Denisovians, if they would have been. They are our cousins. That's what races are. They are races of humans. Denisovans, Neanderthals, Homo sapiens are races of Homo sapiens. And they most definitely, in my personal point of view, they definitely could speak as sophisticated as we can. Just differently, possibly. We will find Beach Price. No, not like the Sopranos. There would have been, there would have been more. What's that high pitched sound that so on? Yes, archaeonomy. Yes, they did. They did went re most with a high pitched sound. Yes. So Neanderthals most likely had brains capable of learning and executing complex maneuvers involving talking. I don't like this statement. I've they did have brains capable of learning. They learned. They had. We are discovering that they had art. That they had complex, even contextualized thinking. So I don't agree with this statement. Their speech would have been, it was as clear as ours and comprehensible as ours, only expressed in a different way. There is a study that the San people of the Kalahari, which have those clicking uh, uh, vocalizations, could have been the original way of talking. And there are studies of those peoples that the way they communicate, it involves hunting strategies. So we evolved because of our hunting strategies, and of course their pitch and the way of communicating would have mimicked that, so they would not have, for example, communicated in the hunt and not actually startle their prey, etc. That's a bit of a that's been studies have been done about that. I will look them up, by the way. Um, their speech would not have been as clear, I don't, as comprehensible as I disagree. Perhaps accounting in part for their extinction. This is uh, no. Philip Lieberman of Brown University of Rhode Island. No, if he said that, I totally disagree with it. Didn't had nothing to do with their extinction. No, we don't know why they went extinct. We don't know why any hominin went extinct. And he says that I think Neanderthals could talk, but more indistinctly than us. I don't agree with that. They could have talked as distinctively as we do. So that's the article I presented. I'm going to click on see if this is the article itself. See if it opens. That's the one. It comes from BioRxIB Beta, and you can see it's an abstract. But if you guys can see here, the download PDF. If you guys want to further read, that's the where you have to click. And this brings us to the end of the article. Now, I have a little bit of a surprise. I have half an hour to have a offline talk with anyone who wants to come on. I'm going to post the link of the Hangout in the chat. 10 people come in. And we'll talk, and I'll stay for half an hour because tomorrow I've got to get up a little bit early. So I'm going to end the stream and post the link. Whoever wants to come on to the after stream party is quite welcome. So everyone else, good night, and thank you for coming along. Next week there is more. See if I can find another one that's a bit longer than today. But this one was quite interesting. So see you around, guys.